So one great thing to include for commissioning your circuits is a test point at important locations in the circuit. So I'm going to include test points, which is just a schematic symbol at 12 volts, 5 volts, ground. I'll probably put one on the signal pin. And these have an associated footprint. So we can put these loops in, and I think there are definitely different types of test points. For example, bridged ones, keystone ones. We have just pads, like surface mount pads for test points that are good for using with pogo pins during manufacturing, like for like a bed of nails testing. But in general for hand assembly, yeah, these beaded ones, these are great. And so then you can include in your commissioning instructions how to assemble the circuit in various stages, like assemble the power supply first, and before assembling anything else, inject 7 volts at V in, test point 1 for 7 volts, test point 2 for 5 volts, and you've got a ground clip at test point 3. And then and only then proceed with assembling the rest of the schematic. Because if you don't have that right, it's just going to ruin your day when you waste your time building a whole lot more of your circuit, only to then find that there's a massive power supply issue or, things of that nature. It can really help during commissioning. There's another neat feature that you can include to maximize the value of your prototypes, and that's to include provisional features or modifiable features using solder jumpers. This is a small microcontroller development board that I whipped up a little while ago. And on the back, we have these test points. Taking a look at the schematic, we have the microcontroller in the center, and there's a few peripheries just coming off the general purpose input and output. There's an addressable LED, and there's also just a standard green LED. But what if you wanted to use those GPIO for some other purpose? Well, you may want to include a cuttable or solderable jumper in your design. These jumpers can be used to reroute signals on your circuit board by cutting or resoldering connections, and they come in a few different flavors. Here's what they look like on board. You can see that it's just a footprint with 2 large pads, and this one is a normally closed jumper. So you would get in here with a knife and cut this open if you wanted to break the connection. It gives you a nice controlled surface to work with. And if you wanted to close it again, you would just bridge it with solder. And so here on the circuit board, I've included a couple of notes: clear to disable LED, and here's a normally closed jumper. It's a little bit tricky, but you can see it under the mask that there is copper underneath. And likewise, clear to disable the addressable LED just here. So solder jumpers come in a few different shapes and sizes. You can see we have the bridged ones, the open ones. This is just for a 2-pad, but they also come in a kind of combinational, like a single pole double throw switch, if you will. So here one is already closed and one is open. Here they're both closed, and here they're both open. And so you can kind of use this to route signals around your board provisionally if you have to. They also make for kind of more permanent settings inputs. You might have a jumper just connected to a GPIO, and on startup, your microcontroller might check the state of the jumper and use that as a configuration setting for something that's never really intended to change, kind of like a set and forget type feature.